All right. So today's session is about package configure and release. And really what we're doing today is we're talking about some additional parts of our product that aren't as intuitive, right? So we know about SCM, we know about CI, we know about security, um, but literally we do maybe around 60 to 70% more stuff on top of that. And so what we're talking about is ultimately having more fruitful sales conversations, having better conversion rates by understanding our complete value offering, and especially understanding these three stages that are outside of our core offering. So things that we're going to do is we're going to talk about why our customers care about it, what this stuff does from a technical perspective, and ultimately how we can incorporate this into our conversations and get higher quality conversion rates. Um, so that's the explicit statement for today's session. Is there anything else that y'all would like to add so that I can tailor this conversation? So maybe something that you've been hearing on your calls that you want to hear more about, or something that I can tack on. All right, let's just jump right into it then. So last time in GitLab, we know about merge requests, right? Our developers are hard at work. They finally hand in their work with a merge request. A merge request is just a change to a code base. After that, our automated CI runs. This is the value of GitLab for a lot of people. And this is what a lot of people think of when they hear GitLab. They think about our CI, they think about our security. But what happens now, right? What happens beyond the CI? What happens after the merge request is finally merged? Well, that's finally what we're talking about today. So literally what we've been talking about so far, if you've taken Tanuki Tech 210 and 211, is these four stages. So our SCM, our CI, our security, things like issues. And what we're talking about today is we're going to continue this story. What happens beyond the merge request, right? So that's what the package release and configure stages are for. So just extending this functionality. And the reason why this matters is because this is how we beat out a lot of our competition. There are some other tools that have integrated SCM and CI. This is what GitHub's really trying to push for right now. But how we ultimately differentiate ourselves with some of these other competitors in the market is by everything else that we have on this table. Literally, GitLab is the only product that has 10 different lifecycle stages, right? So understanding what we do beyond that core offering is how we differentiate ourselves and how we stand out. So that being said, on the right over here is command of the message, right? So our analysts, they basically dug through our Salesforce, found out why we win, why we lose, and then they found out that our biggest three differentiators is that we're a single application for their entire DevOps lifecycle, leading integrated SCM and CI, and built-in security and compliance, right? So this ultimately is why people buy GitLab. So it's important to sort of think about this the right way, as these three things that we just talked about, they're the main dish, right? This is why people come to the restaurant. They want a pad thai, they want spaghetti and meatballs, they want a nice hamburger. But really what we're talking about today is these are like the appetizers, right? So this is the glass of wine. This is the breadsticks. This is something that complements the core offering. So people don't buy GitLab for our release configure and all of that other stuff that I mentioned, but we enhance the meal that we bring by offering additional things. And that's what we're talking about today. So picking up the story, right? We had a merge request, our CI runs, our codes merged. Now what happens? And really what we're talking about today is there's only really three options, and it depends on the type of software that we're talking about. So option number one versus option number two versus option number three, this depends on the customer use case, right? And I'll just give you an example. Everyone here has downloaded stuff from a website, and then you click a button and it says download OnePass version 10.11 or something like that, right? So option number one is that I'm a business, I sell software, and now that I've had my merge request in, I want to make my new version of my software available so that people can download it, right? So let's talk about that and let's dissect a little bit into this use case. So that's what we're talking about with the package section. Literally everything in this package section has somewhat to do with this use case and just ultimately serve these type of customers. So let's actually dissect into what GitLab is trying to do here and some of the value that we bring customers. So package overview. I think that this is maybe something that's better demonstrated than talked about. So I'm just gonna share my desktop real quick. Can you all see my Mac? There should be a black box over here.
Yes.
All right, awesome. So everyone's downloaded stuff from the Mac store, gone online, downloaded things like Google Chrome. But one of the things that y'all might not be aware of is the fact that you can actually download and install things through your command line too. So each platform generally has a different, what we call package manager. So for Mac, the package manager is this thing called Homebrew. So I can do something like Homebrew install this thing tree. I already have this on my computer. It's thinking right now, and ultimately it's going to tell me you already have this package. Yeah, so it's already installed. And let's see some of the other things that this tree thing can do, or that brew can do. So I can search for things to install. I can find information on the different things. I can update things in my system. I can also do troubleshooting and so on and so forth. So the bottom line is that I can install things using Brew. Brew is something called a package manager. And every single domain in tech, so if you're in a Python domain, there's a Python package manager. If you're in the Mac OS domain, there's a Mac OS package manager. If you're in the Windows domain, there's this thing called Chocolatey, and then that's the tool that you use to install stuff. But that's just, the idea with this is that there's just many different package managers that are out here. And so let me just sort of dissect and show the Python package manager too. So the Python package manager and package platform is this thing called PyPy. And if I go over here, I can go find and install and download stuff, right? So let's just go and we can see that there are over 200,000 things that I can download on here. Individually, there's over 3 million files. And people make their stuff installable and findable on PyPy, right? If they want it consumed. That's why there's such a large user base. So I used to work on this tool called Ansible. If I scroll into here, you can see that we can install it. I can download these files here with this button. So I want to take a look at what the actual stuff that I'm installing is. This is a link to the actual source code, and so on and so forth. So PyPy is just an example of one place in which we can install stuff. So let's continue back into the GitLab story. So the whole point with this is that if I want to store stuff on PyPy or many other package managers, then generally there's one of two different ways for me to do it. Either A, if it's some sort of shared platform, then this is an actual SaaS offering. And if I want to store stuff on here, then it costs money, right? So it's an additional account that I have to set up, that I have to create credentials for it. I have to integrate it into my workflow. And ultimately, it's another tool that I have to set up, configure, and manage. So people who install and make their stuff like available on here, sometimes it's free. A lot of the times you have to pay money because ultimately there's some server space that's needed, right? So different types of packages and package registries. If you're hosting it on another website, it's generally at a cost. And if you're hosting it through a package manager on your own servers, then now you had to have an additional server in your environment that you're using for this purpose, right? So what we're talking about is having your own machine that's storing all of these files. That costs money. And it's another thing that you need to set up, configure, and manage. So what we do here for GitLab is that we actually include all of this within GitLab itself. So you don't need additional servers for it. You may actually consolidate the number of accounts that you have, ultimately saving you tools, time, and money. And the specific things that we're talking about here is many different type of files that we can support. So over here on the bottom left, you can see the different package types that can be included in GitLab itself. So if you have things like Go files, Go is a programming language, we can do that. If it's JavaScript, we can do that. If it's Python, we can do that, and so on and so forth. The bottom line is that if a customer ever asks you, what are some of the package types that you support, then this is what we're talking about, this chart on the bottom left. So now let's move on to containerized applications. So who can give me an overview of what a containerized application is? All right, so it's early. I'll just jump right in. So traditionally, like applications have been deployed in one format, and the new and latest and greatest and cool format to package and deploy your applications in this excuse me, in this thing called a container. And the reason why containers are good is because businesses save money and they're able to do things that they weren't able to do before. Right now, maybe around 5 to 10% of the entire market is using containers, but in the next 5 years, the industry is going to consolidate on containers. So this is the latest and greatest and new way of doing things. So this is also something that I think is better demonstrated than talked about. But if I'm an engineer and I want a container, I typically go on this site called Docker Hub, and I can download all this really cool stuff, right? So if I'm an engineer and I need to create a database for my environment, I can go download MariaDB, I can go download MySQL, and then after I configure it, now all of a sudden I have a database running in a container in my environment. It's super easy, right? So if I just click on here, you can see that this has been downloaded over 1 billion times. So it's a hugely popular way of getting applications is using Docker Hub. And there's many other types of applications that I can get off of here. I can get web servers. I can get, if I want WordPress, I can get WordPress on here. So let's actually just search for WordPress real quick. So let's just say I'm starting a blog. I want to run it on my own hardware. It's been downloaded over 500 million times. All I have to do is download it from here. Very easy, very simple. There's millions and millions of people that are doing this today, right? But the problem with using Docker Hub is that you can see that among the official images, there are 166 available images. And so these are images that a business supports, they're vetting for security, they're standing by it. But and then let's now click off of verified publisher, right? One of 400 available images. Now let's talk about all of the other random stuff that people are uploading that we really have no idea who the publisher is and it's not official, it's not supported, right? All of a sudden I scroll out and then there are over 4,300,000 available images. So just for, remember that number, let me go down to verified publishers, that's 400. Official images is 160 versus out of a total of 4,300,000. And basically what we're showing here is the fact that the vast majority of the containers that are on here are completely insecure. Some random person uploaded it. We don't know who, they disappeared, could have a vulnerability. Some of these actually have malicious like problems with them that someone's trying to exploit and get into other people's stuff. A lot of it is just people being lazy, right? And the big problem with this is that this is just how everyone is using getting containers today. And so the point of this is that if you are a customer that needs to go store your containers somewhere, then you can use Docker Hub, create a new account, pay money to do that, integrate it with the rest of your stuff, or you can use GitLab. So what we do with this is that you can actually store your container images in the GitLab server itself. That's one less tool to think about. It's one less thing to configure and monitor and manage and integrate. And you save license costs. And now it's way more consolidated. If you're a security conscious customer, then your GitLab server is on-prem, it's not in the cloud, versus Docker Hub, which is going to be running on someone else's servers. As you can see over here, Docker Hub, the pricing, it just costs per user per month. And so it's just something to think about. Also, in terms of Kubernetes, so brief overview of what Kubernetes is that if we want containerized applications that are running in a kube environment, then it's a different type of downloadable file. It's called a Helm chart. And so there are sites that store this. And the whole idea is, it's just another example of, it's a very similar concept to Docker Hub, right? So here are official and verified publishers, very simple and similar concept. And then I can go find things that I want to install. If I want Prometheus, I can install that. If I want Datadog, I can go install that. But the problem with this and all of these other sites is that they cost money, and is another thing to integrate and think about. GitLab, whether or not you want a Docker Hub account because you're saving container images, or if you want some place to save your Kubernetes installer files, which is called a Helm registry, we actually do that in GitLab itself, which is just another example of tool consolidation. That's the theme of today's session, is tool consolidation. Ultimately, the fact that we can literally save you hundreds of, not hundreds, but many different software licenses and save you a lot of time having to integrate all this stuff together. All right, so moving on. So the Git LFS is something that we hear about from time to time, and I just want to talk about the story of Git LFS. So around 10 years ago, there was a lot of different version control softwares, Subversion and Mercurial, that were more widely used. We didn't really know who the winner was going to be. And then what ended up happening is that the market started consolidating on Git. Git was made by this really famous person, and then people decided that this was the solution that they wanted to go with. The problem was, however, that Git is really, really good for certain types of files, but for large files, Git is actually bad at. So our customers that are producing movies, that are designing video games, that because they're working with like these like 4K video files, like they wouldn't use a Git-based solution simply because that's just what Git is bad at, right? So around 4 or 5 years ago, there was many different solutions that were trying to being created to basically fix this. And Git LFS was one of these solutions that was created. And so this isn't something that only GitLab offers. GitHub actually offers this too. And you can actually get Git LFS outside of either of those offerings. You don't need GitHub or GitLab to use Git LFS. It's something that you can create on your own. So the good thing about this is that this is just another example of tool consolidation, right? So if someone were creating their own Git server, they wanted to have Git LFS, that's more integration and things to worry about. If they want to use it with GitLab, it's all now centralized. There's one UI in which you can look at everything. And it's just another example of how we have functionalities to serve more customers. Now, all of a sudden, we can serve these media production and video gaming companies. All right, can I help clarify any questions about any of the package stuff? But in general, the theme is, this is how we differentiate ourselves, right? We know about SCMCI security issues. All of this other stuff happens beyond the merge request, and it is part of our fundamental value offering. And articulating this as how we can differentiate ourselves from some of our competitors. We are better at all of this other stuff than our competitors are right now. So this is how this is part of our differentiation. All right, great. Okay, so picking up the story. Sorry, did I cut someone off? Yeah.
No, it's okay. I just want to make sure I understood. Basically, as when other companies will have different servers for the downloading of the packages, we do it on the same application. Is it correct?
Yeah, so in general, when we talked about these packages, fundamentally, businesses are creating apps. The apps are getting saved in a certain type of format, right? So just like how when I buy stuff off the internet, it's coming in different types of boxes. Sometimes it's like an envelope. Then the different types of apps, a Python app will come in a certain Python package. A Mac app will typically come in a .dmg file, right? So if I'm a shop that's creating all of these, I need to store all of these files somewhere. And GitLab does this through our package stage. We allow you to store container images, Helm installers, which is a Kubernetes installer. If you're making like a Python app or a JavaScript tool, then we have those package managers that are built inside of it. One thing that I do want to mention is that how we have like these sites called Docker Hub that makes it, like the public be able to download your stuff. That is not something that GitLab does. So it's for housing these artifacts internally. So in other words, if I were a business, I want people to install my stuff, I can put it on Docker Hub. What we do with GitLab is that we house everything internal to the GitLab server, and that's tool consolidation. Sometimes we need less servers, but the story is that customers don't go to our GitLab server and get it. You still need to set that up, but it's so for internal downloading and storing of software in these packages, that's something that we do.
Okay, thank you.
Great. Okay, so we talked about what happens after the merge request. If one of it is that our software is packaged as downloadable packages, then that needs storage somewhere. We can store that on the GitLab server. It's still an additional step to make that available to the public, but at least the immediate step of finding a place to store it, that is something that GitLab does. So now let's talk about option number 2 and option number 3. So let's just say that we're web designers. Fundamentally, we're working on a web application. That's what our business does. And we created a new merge request. That merge request is about updating our website. Now, there's 2 things that we can do with this. One is that we can update our existing web servers because we work really hard at this new feature on our website. We think that it's going to increase our web traffic and we're going to get more money from it. So obviously, we want our customers to see it, right? The other thing that we can do is that we can create all new web servers and kill the old ones. So different customers, they do option 2 and option number 3, depending on their use case. It's not like one use case is better than the other. It just depends on what the customer's application actually is and what they care about. But now let's talk about how GitLab can serve to help out with both of these 2 options. So this is what we're talking about with the release and configure stage. All of this stuff down over here, this is what we're talking about. We're talking about creating new servers. We're talking about updating our servers. And this is basically, great, we got new merge request. How do we actually get this on our website so that now our customers are happier or see the business value of our merge request? So it's important before we dive into how we do it that we have to understand how a lot of our industry is doing it. So around 10 years ago, the method that I'm talking about was basically universally adopted. And what we've seen in really the last 3 years is that the industry is adopting new ways of deploying software applications. So the old way of doing it is that there was just continuous loop. You had your developers, they would they'd work on some code, right? Eventually what they would do is they get a new server and then put their new code on it. So that's the whole develop phase. After that, there's usually another team that comes on, verifies that everything works. And then, so if it's a new part of your website, they'll click on all your buttons and things like that. The next part is that you're going to put it into what they call a staging environment. And what a staging environment is that it's really, really, really close to being put into production. All I have to do is flip a switch and then it's into production, right? So I put it into my staging environment and then finally I flip that switch and then I deploy it. Now it's in production. If I had 10 web servers previously, now I have 11 or 12. right? I added a couple of new web servers to my fleet. And so the big problem with this is that typically there's one team that develops, there's another team that tests, there's maybe a production team that does staging and deploying. And the problem is that every single time, because there's different silos, this entire process might take a month and a half to 2 months. If someone goes on vacation, then the entire process stops, right? So let's just say that there's only one person who knows how to do the final deploy step in a small business. He goes on vacation. Well, all of a sudden we can't roll out our new applications, right? And so this is the antiquated way of doing things. There are a lot of people who still do this, and a lot of people are trying to figure out what's the next best step. I'll give you an example of this. I've actually worked, when I was an engineer, every once in a while, I would have to upgrade around 10 servers. And before we had a good solution for doing this, what I would do is I'd log into the first server, do the engineering stuff needed to upgrade it, and then I would check that wait for the upgrade to finish, check that it actually worked, log out, and then do the exact same thing to the second server, log out, do the exact same thing to the third server, and then basically it was really stressful, right? The entire thing was super time intensive. It was prone to me making mistakes because like I'd be in the middle of the third server, someone would come to talk to me, I'd forget what I was doing. I don't remember like exactly what's needed left, right? So it's basically like really, really, really problematic to do things this way. And unfortunately, many of the people that we talk to still use this type of rollout. So the problem with when people do this manually, I think that everyone's checked the website and they say like, hey, we're going down. Just a warning that we're going down like Saturday at midnight for 3 hours. You can log back in Sunday at 3 a.m., right? And during that outage window, what's happening is that those engineers are actually working on upgrading their website and they're making sure that everything works. That's the reason why whenever you see something like that, that's generally what's happening. And when people do all this manually, one, it's prone to error, right? If someone interrupts me, I go to get coffee. It's very easy for me to forget what I was doing. If I had 20 servers, 50 servers, it just becomes way more complicated, right? It's hard to revert changes because there's no automation in place, and ultimately it's not scalable. So it was a pain for me to do it 10 servers, but imagine for a company like Amazon or Netflix that has 300,000 servers, right? It's ultimately not going to work that way. What this means from a business perspective is that because of all these problems up top, we're going to have service outages. Our customers aren't going to be happy. From a human point of view, we have engineers that are really stressed out that are working midnight on a Saturday. I've done this before. And also, upgrades are released less frequently, right? So from a business perspective, let's just say that we put 20% of our entire budget into engineering. But because of how much work is involved into getting new versions of our website released, if it's this painful, then we're just going to have to do it less, right? So as a business, we're betting a lot of money on something that we're not seeing the highest levels of return from. All it is to say is that many of our customers, they deal with problems like this. I used to be one of them. So let's talk about the modern deployments, and these really have been rolled out in the last 3 years. So many of our customers are starting to adopt them. I'd say that if you're talking with an enterprise customer, they probably have some solution in place like this. But really what we're talking about is using a dedicated tool to manage upgrades and rollbacks. So what a rollback is it's like the upgrade didn't work, let's go revert all of our machines, right? And so ultimately, some of the key components to all these tools is that there's automation, makes things easy, reduces human mistakes. It'll include dashboards for monitoring. On the bottom over here is an actual image screenshot of what GitLab looks like when we're doing a rollout. And as you can see, we can show, so it's like before I had a dashboard, when I was upgrading these 10 servers, like I had to go log into each 10 server, verify that it worked, log out. But maybe there'd be one central console that shows me over here with GitLab, it's 100% complete. How many servers are updated? All 10 of them, right? Are there any in failed, pending, or unknown states? 0. All 10 of them are green. therefore I'm done. I don't need to log into 10 servers, check, and then log out, right? So that's what we're talking about with dashboards for monitoring. And then the next thing is allowing for advanced deployment strategies. If you are Netflix, if you are YouTube, if you are Facebook, you need to have advanced deployment strategies. There's no way that you can be a modern e-commerce or e-video platform unless you have this. So it is necessary for your business. The last component of modern deployments is that they typically leverage the public cloud. And the reason why is because the public cloud is this like vast pool of resources, right? So using something like AWS or Microsoft Azure, I can get 10, 50, 100, 10,000 servers within a couple of minutes. And the ability to scale up and down quickly is something that these enterprises really need, right? So let's just say that like there's some huge release of some blockbuster film on Netflix. There's a lot of people that are watching it. The ability to leverage the public cloud is basically what I need to predict and anticipate some sort of and handle like an event like that. So let's actually talk about some of these deployment strategies now. First one's called rolling deployment. And let me just set the context of some of this. The goal of this conversation isn't so that we're super technical, but the goal of this conversation is so that the next time that you hear about this in an email or customer conversation, you can say, how are your rolling deploys going? Well, that's really great because, and then being able to leverage and be a thought leader, right? And add more customer value to some of these customer conversations. So let's talk about a rolling deploy. How a rolling deploy works is it's exactly how it sounds. So there's 2 servers here in my environment. We turn the first server off, we upgrade it, then we turn it back on. And then once it's back on, we turn the second one off, we upgrade it, then we turn it back on, and then we just go down the line, right? So if there were 10 servers, we would do it from the first to the second to the third to the fourth, all the way down the line. This is the most popular way of deploying new applications today. And there are advantages and disadvantages to it. And let's talk about some of the more advanced options now. And keep in mind, if you had an automated tool of doing this, this would have saved me several hours like every month. And it saves ultimately engineers to be able to do this from an automated fashion using a dashboard to just click things, click the play button. It's a huge time saver, reduces human error, allows you to more reliably deploy the next version of your application. So to be able to do this in an automated fashion is a big deal. All right, so method number 2 is what we call Canary Deploy. If your Facebook, GitLab does this, then you are using Canary Deploys. And so let's just say that like we're working on a new version of our app, right? We're not sure if our customers are going to like it more. So what we do is we'll create 2 environments. One is the new version and one's the old version. What we actually do is that we'll make it so that half of our customers see the new version and half of them see the old version. And then we'll let it run for a couple of weeks. We'll collect data. So has our engagement increased? Do the number of people who are signing up for trials have increased? Is our web traffic increasing? Are we having more sales, right? And so if we find out the answer is yes, then what we'll do is we'll increase it so that now all of a sudden it's 75% the new version, 25% the old version. If things continue to go up, then eventually we'll make it 100% the new version. And that's how we roll out our app. And so GitLab does this for our marketing like collateral. If we're rolling out some new marketing part of our marketing website, we'll do it in a Canary fashion. If we have more engagement, then we'll roll out more of it, and eventually we'll get out we'll remove our old stuff. So that's what we're talking about with a Canary deploy. Long story short, Canary is kind of interesting because it allows you to try out our new change and have the ability to actually get metrics on it. So let's talk about modern method number 3. It's called a blue-green deploy. This is something that is really popular if people use the cloud. But the whole idea is I have a blue environment. So here's all my web servers. This has version A of my website. And now I have some merge requests in. I want to update them. So what I do is I'll create a new environment, which is my green environment. I'll install my new app on the green environment. And then because I'm using something like AWS, I can just flip a switch and now direct all my web traffic to this green environment after I'm sure that it's something that I want. Now, after I flip this switch, then I'm still keep around my blue environment. If I find out that there's some huge bug in the green environment or that there's some big problem with it, I can just flip this switch back. And then that's why I keep around the blue and the green environment for the same time for a couple of weeks. After I find out our customers really like the green environment, it's cool, this is what we want as a business, we can get rid of the blue environment. So that's what we're talking about with blue-green or A/B deploy. So ultimately what we're talking about is great. All that stuff is cool. What do we do from a GitLab perspective? So what we do is we are a great deployment solution if you are deploying to Kubernetes. So whether or not your Kubernetes is on-prem or in the public cloud, we are great for it. If your customers are not deploying to Kubernetes, then you can still get all of this stuff to work. So the A/B deploys, the rolling deploys and stuff, but it takes a lot more work. And so a genuine thing to say is that we have really great functionality if you're deploying to Kubernetes. If you're deploying to virtual machines or to VMware or something else like that, then you can still use our monitoring and our dashboards, but you should also consider using some other tools instead. So let's talk about why that messaging is authentic. I talked to a bunch of the SAs here. When they actually advise enterprise customers, they'll say, use GitLab for SCM, CI, security. When it comes to deploys, since you're deploying to VMs on AWS, it's better to use AWS's tool. We can integrate here. And then that is like the best way to serve a customer, is to advise them with something like that. And this is really what we're talking about here, right? So what we just mentioned, the rolling deploys, the blue-green, the Canary, that's what we're talking about with advanced deployments and release orchestration. So there's a reason why we're a half circle. Our goal is to make this a full circle. And maybe within the 6 to 9 months, we can have a conversation where we say, yeah, you can switch off of that AWS stuff, just use GitLab for everything. But right now it's a half circle and it's important to be authentic with that. All right, so we just talked about updating your servers. Now let's talk about getting new servers, right? And so we have our merge request done. We want new servers that are running the latest version of our website. How do we do this from a GitLab perspective? Well, the answer is that we integrate with this tool called Terraform. Terraform is the #1 tool right now that is used for cloud deployments. And the great thing is that as opposed to having another server that is running Terraform, that is something that you integrate, you can just use GitLab. You don't need an additional server, and now everything's already integrated for you, so your engineers don't have to spend a lot of time writing out that integration. So it's a great way to save time, money, business value, allow your engineers to work on something else. So that's one of the things that we do. What Terraform basically does is that you tell Terraform, hey, I want 5 new servers in AWS Cloud. I want to have these things installed on it. And then Terraform goes out and then does that for you. So if you don't want to use Terraform, like something like Ansible, we support that too. And there's a lot of blog articles that you can send to our customers. And let's just say that you want a new Kubernetes cluster. GitLab is really great for Kubernetes. We're trying to build out a lot of features around Kubernetes. We allow you to do that too. Whether or not you want it in Google Cloud or AWS Cloud, we actually allow you to create new Kubernetes clusters through GitLab. So that's something that we also should know about. Can I help clarify anything that we've been talking about? I know that we just jumped through a bunch of different topics real quick.
Chris, I have a quick question around you mentioned the old type of rollout. Does it have an umbrella term, the old type of rollout name?
Not that I know of. It's something like, I think that in general, like a good question to ask is like, what does deploying to production look like for you? And then if they say, we have a bunch of teams that they do it, they update all their servers kind of manually, then that tells you something. If they say, oh, we use some sort of automated deployment tool, or then that also tells you something too. But it's not like there's a
Yeah.
term for like waterfall versus agile, right?
Yeah, understood. Yeah.
Thanks for asking.
And just another quick one, is there a new terminology for the new ways of deployment, which we just described?
Yeah,
There's
so
also not.
if I were trying to use this as a selling point, we already talked about SCM, CI, security, and then we asked a question in the beginning, like, what are some of the strategic initiatives that you have in your business? And they mentioned, we're really interested in modern deployment methods, so we're investigating some tools right now. Generally, I don't hear that, but let's just say that you do hear a case like that, then we can say, oh, are you thinking, what sort of methods are you talking about? Are you talking about blue-green deploys, Canary? I'd be happy to walk you through the pros and cons of each and how GitLab can serve in this capacity. And then all of a sudden you've hooked into another factor of like how we're differentiating ourselves from a GitHub or something like that.
Awesome, thank you.
Yeah, for sure. Thanks for asking. All right, so let's start wrapping some of these things up. There's only two additional things that I want to talk about, and these things aren't selling points as much, but there's just something that you might see in a customer email from time to time. So I'm trying to equip you with the knowledge so that you can respond to the emails quickly and save you time. The first one is this thing called GitLab Pages, and this is a core feature. This isn't something that we try to sell on, right? But we will get emails from it from time to time about someone who's interested in it. So what we're talking about here is that we are going after the simple website market. And what I'm talking about with that is that a lot of times, if you want a nice, responsive, fancy website, you go hire some contractors and you pay them $100 an hour to go do it. But for most people who it's like a restaurant or it's some sort of like a flower shop, they really don't need all that fancy stuff. They need a really simple website. So have you ever heard of like Wix before? We're talking about something like that. So what a lot of people do over here is you can see that all of my code is housed on over here in GitLab, right? So if I go and look at some of these blog posts that I have, right? So here's a bunch of automatically generated Latin. But what GitLab's actually done for me over here is that it's actually running my website for me. So literally, I don't need to create a new web server. GitLab is hosting this on the GitLab platform. And then so this is the website that corresponds with this code that we were just looking at. If I go into the blog section, I can actually find out this text that I was just looking at over here, this file corresponds to this portion of the website. So if I were to go into here and let's just say like if I click this edit button, I can edit all this code and then I can make it so that GitLab can just update my website for me. That's how simple it is. So why do we care about this? Because this is a core feature. And part of the reason why we care about this is because GitHub does this too. So if they do something, we need to do it as well. But the other part of it is just take a look at this web address, right? So pages.gitlab.io. And so all of a sudden, there's now a new website out here that is advertising the GitLab name, right? And then so more time people see GitLab, hear about GitLab, that ultimately is going to relate into more conversions for us and just more visibility on the internet. So this is obviously one way to help out our business. That being said, if you're using GitLab Pages, do you need to have a web address like this? No, you can change it. But do a lot of people, are they lazy and they just keep the gitlab.io in there? Yes, right? And so it's just good visibility for our platform. So that's what we're talking about with GitLab Pages. If you ever hear things like someone's using Gatsby or Hugo or Middleman, that's what we're talking about. And so GitLab's really good at this. And this is something that GitHub does as well. And the last thing I want to talk about is feature flags. And so I personally, as an engineer, I don't like feature flags. Some people really like feature flags. So we have to have that functionality for them, right? But what we're talking about with feature flags is it's a new way of doing things. So I said previously in the beginning of this session, there's really only three things that our engineers are trying to do, right? One is that we need to create a new downloadable package. One is that we need to update our servers, and one is that we want to create new servers, right? So that's a little bit of a lie. There's a new methodology of pushing out changes into your servers, and that's what we call feature flags. In practice, less than 1% of the market uses feature flags. So most people don't know about it. Most people don't care about it. Me personally, as an engineer, I don't like it. But the whole idea with it is that it's a lot of work to do a deployment, right? So you need a tool for it. You need to do all this Canary stuff. You need to do a rolling deploy. With a feature flag, you actually write your application in a way so that you can actually switch new portions of your site on and off. And then so if I created some new like button or something or whatever, or a new chart, I can write the code in a way so that like in a dashboard, I can click this on and then boom, all of my customers, when they visit the next version of our website, they can see this change, right? And then if we find out there's some problem with this code, I can just click this off. And so that being said, there's a couple of components to this. GitLab gives you the nice UI in which you can just go into the feature flag section and then toggle on and off, but you actually have to write your applications in a way to use this functionality. So your engineers actually have to create your applications around this functionality. My personal preference as an engineer is to not use this, but there are some people that will ask about this. So, and then ultimately, why do we care about this? Is that to reduce risk, right? So it's a lot of work, time to do a deployment method. Even if you have an automated deployment solution, then that's still going to take some time if you have 10,000, 100,000 servers, right? But if you have feature flags, you just have to toggle this switch. And then your website will update automatically for you. And then so that's why some people are moving to feature flags. So that's and just sort of like bringing everything home, right? So we talk about how we are one tool for the entire DevOps lifecycle, and we talk about license consolidation, and we also talk about less integrations. So let's just talk and review about how we did that today. Things that we discussed is needing servers to serve as package managers, either a server or having an account on some other SaaS for your container images, your Helm charts, additional servers potentially for Git LFS clusters. Talking about provisioning tools, right? So something like Terraform, deployment tools, and also like generating simple websites. So literally what we are talking about here, when we say that we are one tool for the entire DevOps lifecycle, these are engineering attempts for us to actually make good on that. And as opposed to now needing 5 different tools, 5 different accounts, 5 different environments, 5 different integrations, now I can just have GitLab, which saves me time, money, allows my engineers to go do something that's higher value for the organization. So that's basically what we're talking about today. So that's the end of today's session. If you want credit for the class today, fill out the test that's going to be generated for you momentarily. And if anyone needs to hop off, thanks for coming today, but I'll stick around for another couple of minutes for some questions. Thank you all for coming today.
Thanks, Chris.